Good morning, students. This being the continuous process, learning, and hopefully in the last class we had a resistivity discussion. Resistivity is given by 1 upon conductivity, where conductivity is defined as n square tau upon m. Since it is in the denominator, I have written resistivity equal to m upon n square tau. M stands for mass of electron, E stands for electronic charge. Both are going to be a constant for everywhere, in the sense for all materials. This n happens to be number density, number of charge carriers. This is called collision time, average collision time. Now, what is the next learning process? We studied conductors. Yes. Now, resistivity, how it is related to temperature. We had a small graph where it was like rho, it was like temperature, I hope. And we had a small graph. What is the graph? The graph was like this. Means with increase in temperature, resistivity increases. And resistivity is measured in ohm meter. Yes. Now, how to cross check? I had a formula. So looking into the formula, this resistivity is directly inversely proportional to 1 upon n. Similarly, it is inversely proportional to 1 upon tau. Yes. With increasing temperature, this n remains constant for metals. Whereas collision time decreases. Now, question is, with increase in temperature, n remains constant for a metal, number density of electrons remains constant. Yes. What is this collision time? Why it decreases? Now, question, take it out. When temperature increases, your speed of charge carriers, that is electrons, increases. I repeat, with increase in temperature in case of metals, the speed of the charge carriers increases. When it increases, frequent collisions, more collisions, frequent means more collisions or frequent collisions will take place. Frequent collisions occur. When frequent collisions occur, the time between two collisions decreases. What I mean to say, with increase in temperature, we want to check with respect to metals. I want to rectify this graph. So whenever there is an increase in temperature, as I increase temperature, what happens? Resistivity depends on n and collision time. For metals, n remains constant. Now only the variable parameter is collision time. So this remains a constant, no issue. When it comes to collision time, this collision time is decreasing. Why it is decreasing? The analysis. Whenever temperature increases, the electrons, they are called charge carriers. They are constant in number. They acquire more speed. When they acquire more speed, they vigorously move in a material and they collide with ions. When they collide with ions, these collisions are called more frequent. Collisions are more frequent. When collisions are more frequent, we are going to say they occur more frequently. Hence, the time between two collisions decreases. When this decreases, naturally this collision time is going to decrease. With decrease in it, naturally your resistivity, as with the formula, definitely it is going to increase. So this is the analysis. I repeat, whenever metals are subjected to increase in temperature, means temperature is increasing. What happens to copper? Copper exhibits more resistivity. It means more opposition in that way. Whenever that happens, what is the reason? With increase in temperature, naturally, the charge carriers acquire more speed. They collide more frequently. When they collide more frequently in a given time interval, the time means the collision time decreases. Means in a collisions, because the speed increases, the distance, take for example, the distance between two ions remains constant. This distance is constant. If the speed is more, V equal to distance upon time. Time comes here, speed is more. So what happens? This whole time becomes small. You have a simple formula. Velocity equal to distance upon time. If the distance between two ions, ions means positive course, remains constant. If the person who is going to collide between this ion and this ion, it is going to move with a more speed. So it starts here, it collides here. Why the speed is more? Look at the formula, time equal to distance upon velocity, velocity more, the distance fixed. Then velocity and time are inversely proportional. When velocity of the charge carriers increases, time decreases. That time is called collision between two electrons decreases. Hence, my resistivity definitely is going to be more for conductors.